Hey everyone, still talking about where data comes from. And the first kind of step in this is looking at sampling methods. We've done some already. We've talked about biased ways of collecting data, which was the convenient sample and also the voluntary response sample. Those are very bad. And then we also talked about a good way, which is the simple random sample. But in order to be as representative of the population as possible, sometimes there's some other random sampling methods that are even better than just taking a simple random sample. So here's our situation. Edge Vista wants to know if students want more live Zoom sessions or fewer live sessions. Some students find it pretty helpful to have a live teacher with them. Others think it's like, waste of time. Why not just post videos and I work on my own pace? So just for simplicity, we're going to assume the population at PV is 800 students. And within these 800 students, we've got these kind of categories. We've got some freshmen, there's 240. And typically, the seniors is going to be the least represented class. A lot of kids drop out, graduate early, transfer, whatever, by the time they reach their senior year. So you can see that we've got 240, 200, 200, and 160 seniors. So these random sampling methods, some more of these. There's three altogether. The first one we'll talk about is the stratified random sample. Stratified random sample. Not an SRS, but this one is stratified. So what you do in a stratified random sample, well, let's get some more information actually. So they want to know if students want more live or fewer live sessions, and they plan to sample, PD administration or whatever, they plan to sample 80 students. So of the 800 students that attend school, they want to get a sample of 80 and see how they feel about the Zoom sessions. This is because trying to get a response from all 800 students would be very difficult. Making that sample 80 and just drawing conclusions from that is going to be a lot easier than, again, from all 800 students. So the stratified sample, why we use this is because say PV just got like the student IDs of all 800 students, threw them into like some random number generator, picked 80 of those students. It could very well happen that almost all 80 students that they chose were freshmen who maybe want more live sessions because they need more help. Or maybe they picked almost all seniors where you're more independent at that point in your life and you don't think you need as many live sessions. So to be as representative as possible, we want to have equal proportions in our sample. Since there's more freshmen in the school, we would want more freshmen in our sample of 80 students. Now, stratified comes from this word called strata. So strata refers to groups that share a characteristic. Groups that share a characteristic. So the strata in this situation, the characteristic that we're grouping the individuals by is grade level or grade classification, I guess. So the strata here is the grade classification. Freshmen, that's the characteristic that these students have in common. Sophomores, this is the characteristic that they have in common, and so on. So to do the stratified sample, remember, we want to choose 80 students from the 800 altogether. And to do this, we are going to try to match proportions. So we need to randomly select some freshmen, randomly select some sophomores, some juniors, some seniors, and have that all add up to 80. Not the hardest thing to do. So let's think about how many freshmen go to school at PV. How many of the students at PV are freshmen? So what we'll do is find the number of freshmen. So the number of freshmen that need to be in our sample, all we'll have to do is take the actual proportion, so 240 divided by 800, and then multiply that by the sample size, which is 80. So I'll get a calculator out and show you. 240 divided by 800. So, hey, it looks like 30% of the school is freshmen. So in our sample of 80 students, we want about 30% of that sample to be freshmen. So that's why I'm just doing 0.3 or 30% times 80. It's 0.3 times and 80. So in this sample of 80 students, we want 24 to be freshmen. Now we'll do sophomores, 200 over 800. So I could just actually write it out for you. 200 over 800 times 80. So again, we're getting the true proportion for sophomores at the school and then multiplying that by our sample size. 200 out of 800, so 25% of the school is sophomores. Then we'll multiply that by 80. So we get 20. We want 20 sophomores to be in our sample. So juniors, it's the same proportion. We have 200 juniors out of 800 total students. Multiply that by the sample size, or at least the desired sample size, and we'll get 20 students there. And lastly, we'll do the seniors. How many seniors should be in our sample? So seniors, we've got 160 students divided by 800 students altogether times the sample size, and we'll get what would we get? 16, right? 160 out of 800 times 80, and you get 16. Awesome. So this is going to be like guaranteed to be representative of the population in terms of this characteristic or this strata. Again, if we would have done just a simple random sample, it could have been that we got like 40 freshmen, only 10 sophomores, like 5 juniors, and then however many seniors. So the stratified sample is very, very powerful. It's really, really helpful to do, to be representative of the population. It almost guarantees it. Now, there's another step in this, of course. So we know the number of students that we need, but we don't know which students we're actually selecting. So now that we know we want to select 24 students that are freshmen, we can conduct an SRS, or a simple random sample, of this group. Conduct an SRS of the 240 freshmen and select 24 of them. So once you get your amount in each strata, then you can conduct an SRS of that group. So of those 240 students, we're going to randomly select 24 of them. And that's really it. So to do the SRS of the group, you could number each individual, use a random number generator, and randomly select students until you get 24 of them. Move on to the sophomores, repeat that process, but you're only selecting 20. You could use, like that table of random digits or whatever. All right, so that's it. That's what a stratified random sample is. Now this next one, the other random sample, it's called a cluster random sampling. So this one's quite a bit, I don't know, it's pretty similar to stratified, but it's like different as well. So the cluster is where we're not classifying the groups, we're not putting them into strata, they're not sharing a characteristic, but with the cluster random sample, you are grouping by location. Grouping by location. So what you could do for this one is, in like your Zoom classes, maybe your English class is probably the most applicable. Like you have English 9, English 10, English 11. So what you could do is, for your clusters, is find like a freshman class. Find a freshman class. I should say actually randomly select a freshman class with approximately 24 students. Randomly select a freshman class with approximately 24 students. So you have this list of freshman classes to choose from. Maybe you get the ones that are pretty close to 24 students. And then from that list, randomly select one of those. Do the same thing for the sophomores. You would randomly select one of the classes, one of the sophomore classes. It's going to hopefully have around 20 students. And every student in that class will then complete this survey, or will at least answer this, this question. So that's what cluster is. That's really it. You're grouping by location. So to not get confused between stratified and cluster, because they are pretty similar. What you do with stratified is group people into strata and take some from all of the people in that group. Maybe I can just write this down to kind of clarify between cluster and stratified. So from strata, from the stratified sample, you select, I'll just say some from all. In clusters, you take all from some. Kind of backwards, essentially, right? In these characteristics, I was randomly selecting people from that group. I was randomly selecting some people from this group of juniors. Whereas in the cluster, I was taking all of the students from this class. And so that's the big difference between stratified and cluster. Awesome. So cluster is definitely easier to do, requires a lot less effort, but stratified is a better way of guaranteeing that you are representative of the population. The last sampling method, it's another one that's kind of like easy and decent. This last one, it is called a systematic sample. Systematic. So with a systematic random sample, you will, for systematic, you choose a number. You choose a number. Then randomly select every nth individual. So just for an example that relates to this thing that I already talked about, the school would have like all students listed alphabetically, number them from 1 to 800, and then they could just say, hey, we're going to start with student number 5, and then, well, we could actually do it on a calculator, I suppose. So we have 800 students divided by 80, right? We wanted 80 people in our sample size. So 10 would be the number that you skip. So I guess I could put it into words here. So like, for example, start at student 5, whoever came 5th in that alphabetical list. Then select every 10th student afterward. 10th student after. And by following that process, you should end up with exactly 80 people in your sample. It's like you would select student 5, then you'd select student 15, and then you'd select student number 25, 35, 45, on and on and on. And then once you get to over 800, then you'd already have your sample size of 80. Okay, so that's gonna do it for this video. Just realize that there are more ways to sample than just dropping names in a hat or whatever, right? There's more ways than just doing the simple random sample. You could do a stratified, you can also cluster, and there's also the systematic way of sampling. All right, y'all, so that's gonna do it for this video. Thanks for watching. I'll see y'all in class. Goodbye.